Hello and thank you for watching the third lesson of Chapter 1, which is 1.3, Switching Domains and Communications. In this lesson, you will learn about two different types of duplex communications that we have, as well as collision domains and broadcast domains. In this lesson, I'm going to jump in straight to the packet tracer and continue where we left it off with lesson 2. So I'm going to open that packet tracer, so File, Open, select lesson 2 packet tracer and click open. There we go. This is where we left it off from the second and the first lesson. So you need to learn about two different types of communications that we have. We have a half duplex communication, so half duplex, and full duplex. Now, full duplex. Half duplex communication is a unidirectional communication, which means only one device can send or receive at a time, and operates like hub will operate at that communication, half duplex. So if these devices are connected to the hub, only one device can send or receive at a time. If two devices they attempt to send at the same time, there'll be a collision, which we're going to see it very soon. While switches, these are layer 2 devices, layer 2, hubs are layer 1 devices, switches operate at the full duplex communication, which a device can send and receive simultaneously. So there's not going to be a collision, right? So switches in reality, they're going to increase the bandwidth performance because they allow send and receive simultaneously, to send and receive data. If you have a port, there's a gig port, gigabit Ethernet, that always works at full duplex, yeah? So duplex. So gigabit port is never going to work in half duplex. If we go back to the half duplex, these devices connected to hub, if a device needs to send something, for example, this is a source and it wants to send something to this destination here, this device is going to run a protocol called carrier sense multiple access. It's going to listen to the carrier. Everybody has access to it. Listen to the carrier if somebody else is sending. If nobody else is sending, it's going to start transmitting data. When that data arrives at the hub will regenerate the data and it will send it to every port apart from the port they came in. So it will flood it. If two devices they start sending at the same time, there's going to be a collision. And when there's a collision, these devices they will be able to detect it and they will send a jamming signal saying to everybody, stop, don't send anything anymore, run a random timer. After that random timer reaches 0, then they will start again. They will listen to the carrier, everybody will be access, multiple access, and collision detection. Right. This is what we're going to do because we have the hub there. So we're going to connect a hub. Well, we're going to send some data from two devices at the same time and we'll see what happens. Okay. So what I'm going to do, just drag this here on this side. So what I'm going to do is this device is going to send as a source to this destination. At the same time, I'm going to send from here to here and see what happens. Yeah. Okay. So if I start this device and this device, and I'll bring him into, okay, here is .20 and here is .10. And if I go to desktop of .10, go to command prompt and just type ping the IP address of the 40, and then here I go to desktop command prompt and I'll ping the 30. Yeah, so ping 10.1.1.30. I'll go to simulation mode and look at those two, just ping them, just start the ping. Right, if these two devices that send data at the same time, what's going to happen? They're going to go to hub, boom, it's going to be a collision. They can't send two devices, they can't send data at the same time. So they have to listen to the carrier and then send data, right? So when there's a collision, they're going to run the jamming signal and then they run the random back off timer and wait, and then they're going to send it again. Well, if I move here to say these two devices, so just want to show you that this one is .10.20, but I'm going to bring this 10 and this 20, which is different to these two, yeah? Already these two. But this 20, the second 20, which is this one here, and the second 10, which is this one here. And again, I'll open the command prompt, ping address up there, 10.1.1.40 on this side, and I'll ping here. I'll ping the 10.1.1.30, which is this one. I'm pinging from here now to this one here. Say press enter here. Now you can see in the switching, it's fine. They all work at full duplex. So the communication is fine. It will work, right? We're going from the source to destination. Let me just move this slider so the traffic goes faster. There we go. While in the hub, I don't know what's happening in the hub. Is they are stopping, right? Let me go here. Repeat the command maybe. Okay. The hub, you see, it's not going to work. There's always going to be problems here in the hub. Right. So there's a full duplex and half duplex. In a full duplex communication, full duplex, the devices can send and receive simultaneously, and they don't run that carrier sense multiple access. While with a hub work at half duplex, and devices they have to listen to carrier sense, multiple access, collision detection. If there's a collision, they will start again. You see, we have a bit of problems here. Okay. Now let me change the IP address. I think it could be the problem with IP addresses here. No, it can't be the IP address. Okay, let me clear this up. And the next thing we're going to be talking about is what is, let's go to the slides. So duplex communication we have, if we connect, for example, hub and the switch, they have to be half duplex because switch operates at the full duplex, but the hub operates a half duplex. So in this type of communication, only one device can send or receive. If two devices send at the same time, there's going to be collision. If there's switch to switch, it's a full duplex connection. So then you can send and receive at any time. There's no problem. Now you can tell the device to operate. For example, by default, the duplex will operate at the auto. So device will auto negotiate with the other side what duplex I'm going to use. You can force it to be full or half, which is not recommended. You should always kind of leave it to auto, so it will negotiate. But if one side is forced to be full, then the other side, if it's a switch, it's going to be full as well. You can also force the speed. So speed by default is auto. You can force it to be 10 megabits per second or 100 megabits per second. And if you do that, the other side you have to work properly, you have to force it as well. Now, Auto-MDIX, now if you connect devices, two switches together, then you need to connect it with a crossover cable. But with the new switches, they have this feature called Auto-MDIX, and MDIX stands for Medium Dependent Interface Crossover. What this is going to do, like for example, if you do connect a straight through cable, an Auto-MDIX feature is on, it will find out that, okay, well, the other side is a switch, so let me correct the cable, put it as a crossover cable. So automatically detect required cable connection type and configure the connection properly. Therefore, either type of cable can be used to connect to other devices. So for example, you remember, if I connect a PC to PC, similar devices, right, I do need to connect with a crossover cable. If I connect a router to a PC, do you remember what cable? Straight through, yeah? Is it straight through? Is it crossover? Because router and a PC are similar devices, so they need a crossover cable. But if Auto-MDIX is running, then you can connect it with different cable. The switches, yeah? Or whatever device supports Auto-MDIX. One thing about Auto-MDIX is the duplex, let me write there, duplex, and the speed has to be set to auto. So duplex have to be auto and speed has to be auto. So, and then the MDIX, it's auto. It's fine. It will work. For some reason, if somebody changes the duplex, for example, from the auto and makes it full, for example, or maybe the speed makes it 1000 megabits per second, it changes to something else, then the MDIX will fail. So MDIX requirement is duplex to be auto and speed to be auto. As soon as you change the duplex and speed, the MDIX will fail as well. So really, if you can, always connect it with a crossover cable. If you similar devices connected with the crossover cable, don't rely on MDIX, because as soon as somebody changes the speed, MDIX will fail, the cable will fail, these two devices will not be able to communicate with each other. Okay, so let me go back to my packet tracer that we were using here, and I'm just going to change the IP address of those PCs. So put this as a, for example, 50, this PC to 50, and this PC to 60. So desktop 60 here, and this PC to 70. So go to desktop 70, and this PC to 80. So close this, desktop 80. There we go. So change it here as well. Dot 50, 50. This one 60, 70, and 80. Right. Okay. Then I'm going to connect these two devices together, this switch and with this hub. So what cable do I need to use? Do I need to use a crossover cable or straight through cable? Well, because it's similar devices, you need to use a crossover cable. So I'm going to connect switch with port 20 to hub port 4, right? And there we go. Let me just move this if I can a little bit, so you get to see a little bit the port. Yeah, it doesn't show very well. Okay, but you can see the switch is actually running. It's orange. It's orange, while the port in the hub is just green, because the hub doesn't, like for example, doesn't look for um, loop prevention, while the switches are a bit more intelligent. They have a look if there's a loop prevention. Okay, let me just get rid of these port numbers. So option preferences, and show port labels, get rid of that so we can see a little bit better. Okay, and you can see the now the port is all green. Okay, now we're going to be talking about collision domains. So what happens if where is going to be a collision? If one device sends here, what other devices are not allowed to send? For example, can this device send? Yes, it can. Can this device send? No. At the same time, no, because there's going to be a collision. So as all these devices from this port on the switch and all these devices, there is here, it's one collision domain. While switches, on the other hand, they break the collisions. So every port or every active port on the switch is a collision domain. So here, this one is one here, there's one here, there's one here, and there's one here. So in total, we have 5 collision domains here. So these devices, when they connected to the switch, they don't need to worry about the collisions. Yeah. Okay. Now, if when the device sends, for example, a frame to the switch, do you remember what the switch did from previous lesson? Switch looked at the source MAC address and it builded a MAC address table or CAM table, right? CAM table. And that CAM table was VLAN, which we're going to learn more next session. But it was like port ID, what port it is, and what MAC address or MAC address to port number. And then it will add this MAC address from the source. It will put it on the MAC address and what port they came in. And if the destination is on this table, it will forward it directly to the destination. If destination is not on the table, it will flood it. It will behave like a hub. It will send it to every port apart from the port they came in, right? It will send it this way. When it gets to the hub will always flood. Doesn't matter what packet it will or what frames, flood everywhere. Now switch will flood for unknown unicast address, and broadcast, and it will flood for multicast. It will flooding. While the hub will flood always. Known, unknown, it will just always flood, okay? So if I go to this PC, and we can see the MAC address table, like what's on the switch, what's in the MAC address table. So if I go to the switch and just do show MAC address table, let me increase this. Show MAC address table. Switch doesn't have any MAC on this table, because when it's brand new, all the information there will be 5 minutes, but even when it's booted, it's all empty. Okay, so I'm gonna ping from this PC to this PC and see what happens. Yeah, go to simulation mode and ping from there. So I'll go to that PC, open the command prompt, and just, you can't see it very well, but let's move, if we can move this right. So ping 10.1.1.1.40. So I'm pinging from here, PC1, to PC.40. Press enter. Now you can see PC is sending, what is sending? Is ICMP. Because PC already knows the MAC address of 40. If it didn't, it will send a broadcast, yeah? So let me look at what is the MAC address. So ARP minus A. So the PC, you see, already knows the MAC address of 40. So for that reason, the PC is not sending a broadcast ARP, address resolution protocol, to find out the MAC address of the device, because it already knows. So automatically it's generating ICMP packet, right? ICMP packet. But the switch, on the other hand, it doesn't know where is the .40, where is the MAC address 9580. Since it doesn't know, the switch will take that frame, will add the MAC address of .10. So if I look at the table now, so look, 4E9A is being added in port 24, right? It says, okay, well, port 24, that MAC address, 5 minutes is going to be there. But the destination is 9580. I don't know where the 9580 is. So because I don't know, I'm going to send it to every port apart from the port they came in. So I won't send it back there, but I will send it to every other port. Now this PC has ignored it and this PC has ignored it. The hub, it will just replicate. It will send it to every port. Now the device is actually replying. So all these devices, they just got, like, for no reason. Now .40 has just replied. And if you look at the switch's MAC address table, now switch has learned the 9580 port 23, 4E9A port 24. So since the switch knows, now it's just going to forward it directly to there. And the next ones, they're just going to be sent. Yeah. So let's see why is it not pinging? Ping. Go to real time. Yeah, we have a reply. I don't know why the first packet didn't. It was not working. But you can see you can ping the 40. No problem. Let's have a look. Like for example, the 30. If I ping the 30. So ping 30. Now PC doesn't know where is 30, so it's going to send a broadcast address resolution protocol packet first. And that's a broadcast. Switch will behave like a hub. It will just send it to every port apart from the port they came in, right? And the hub just going to send it to every port anyway. And then that's replies. And after the 30 has replied, the switch has learned where is the MAC address of the 30, and it'll just forward that to the destination. And then now the pings will work. Okay. The next thing is I'm going to ping from 70. So I'm going to ping from this device, and I don't want this video to be too long. So I'm going to ping from this device. This is the source and this is the destination. And you see the hub is just going to replicate. It's going to flood it to everywhere. Yeah. Okay. So if I go here and I'll stop that and delete this and go to 70 and ping the 50. So command front. Cancel this. Ping the 50. Okay. Now the device doesn't know, so it's going to send an ARP, so it doesn't know where the MAC address. So it's going to send ARP. That's a broadcast. It will go to the switch. The switch will broadcast that, will flood that as well, yeah. And the 50 is replying, but that hub is just going to flood it anyway. Then the pings, the hub is just flooding it, right? So you see the hub is flooded while the switch does not flood it, right? Okay. So if I go back to the slides here and collision domains. For example, if we have a, for example, collision domain, say this is the source, so source, and this is the destination. How many collision domains do you think there is here? You can pause the video and just count them. Just one. One collision domain. So all these devices, they have to listen to the wire if somebody else is sending. If he starts sending, if there's a device here that needs to send something, has to wait till it's finished. So when he goes to the hub will replicate it. It will send it to every port, right? It won't send it back. It will just send it to this hub, then to this hub, then to this hub. They will go to every port, right? And go this way as well. You see the point. Everybody gets it. Just because these two devices are communicating with each other, every device actually going to get that communication. So it's one collision domain, right? If I change this little bit, so I have added a switch here, as you can see, switch here, switch here. Now, how many collision domains do we have? Well, there's going to be one collision domain here. There's going to be a collision domain here. So all these are going to collide, and these can collide with each other. So 3, and there's a between the two switches, so 5. So switch to switch and switch to another switch, 5 collision domains altogether. So if one device here starts sending, another device cannot send because there's a collision domain. However, device can start sending on this side because that's the collision domain here. It doesn't nothing to do with this side. If I change a little bit, so say I'll change it to here. So now everywhere, everything is switches. So how many collision domains now? Now you can send and receive at any time, yeah? So we have a collision domain here. So 1, 2, 3, 4, 5. Every active port on the switch is pretty much 7, 8, 9, 10, 11, 12, 13, 12, sorry, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 collision domains. They don't go through the carrier sends in here because they can send anytime. Now, what about broadcast domains? So broadcast domains, when you think about not collision domains, but broadcast domains. If I send a broadcast, right, switches that behave like hubs, they're gonna send it to every port apart from the port they came in, right? So this is still just one broadcast domain because every port gets it. The switch behaves like a hub in a broadcast domain. So we have whatever collision 27 or whatever it was, collision domain, but broadcast domain only one. Okay, the next, if you want to reduce the broadcast domains, we can either do the VLAN, configure the VLANs, or add a router, like we did here. So we add the router. Now router, every interface in the router is its own collision domain. And I have given you like a challenge here now. I know it's a long video, but I've given you a challenge. Have a look. How many collision domains and how many broadcast domains do we have? Okay, so I hope you found that correctly. 16 collision domains and 3 broadcast domains. So because you see, you have to pay attention because that's for a reason I put this hub here. So pay attention to these icons. You can see there's a hub, so all this is one collision domain, right? And then the rest we counted it. Excellent. Thank you very much for watching this lesson, lesson 1.3, communications and domains. This is of chapter 1, basic device configuration. Please have a look at my other videos in YouTube channel and don't forget to subscribe. This has been Astrid Krasniqi. Bye bye.